Hi everyone, my name is Grace Farrow. I'm a Solid Edge Application Engineer here at PROLIM, and I will be going over Solid Edge 2020 simulation with you today. So one of the main things that we're going to talk about is the simulation tab. I'm also going to go over creating a new linear study. We're also going to talk about creating a new heat transfer study, and then we're going to look at how we can evaluate the results in 2020. So let's get started. So I've opened up my Solid Edge, and I've gone automatically to the simulation tab, and we are going to look at this tab for the time being and go over the groups as well as the loads and maybe just some overall explanations of some constraints or connectors. So when we create a new study, we will go from the left side of the ribbon to the right. So that's how we're also going to look at all of the different commands today. So on the left side, we have the select group. Pretty self-explanatory. We've seen this before. This is a new group for us too, so this is the study group. This is how we will create a new study. This is also how we can select a material either from this drop-down or from this material list. And then we do have a new optimization. So what that is that changes the study geometry based on simulation variables such as load, stress, deformation, strain, and natural frequency. And then we do have the geometry group. So this define command, so that is used to select the geometry that we will be analyzing. We do have structural loads as well. We have force, which applies a force load to selected entities. We have pressure, which applies a pressure load to selected faces. We also have torque, which applies a torque load to selected faces. Displacement applies a known displacement to selected entities, and then bearing applies a bearing load to selected faces. And then if we go to the body loads, we have three in here. We have our body temperature, which applies a default temperature to the entire model. We have centrifugal, which applies a centrifugal load to the entire model. And then we have gravity, which implies a gravity to the model. The next group that we have are our thermal loads. We have temperature, which applies a temperature to selected entities. We have heat flux, which applies a heat flux load. We have heat generation, which applies a heat generation to selected components. Convection, which applies a convection load to selected entities, as well as radiation. We're going to look at a couple of these today as well, but just to get a general overview, I'm just going over all of them for the moment. And then we have our function group. So this creates a function to define a time-dependent loading a variable input to a transient heat study, or as frequency-dependent modal dampening in a harmonic response study. Okay, we're also going to look at creating a function in 2020. We're going to do that with our heat transfer example. And then we also have our constraints group. So we have 6 in here. Generally, the two that I've seen used a lot is this fixed and pinned. So fixed fixes all 6 degrees of freedom. Pinned fixes the 3 translational degrees of freedom, while rotational degree of freedom remains free. We also have no rotation. That fixes the 3 rotational degrees of freedom, while the 3 translational degrees of freedom remain free. And then we have sliding along a surface. So what that is that creates a sliding along surface condition on a planar face. And then we have cylindrical. That constrains radiational growth, rotation, around axis or sliding along axis for cylindrical faces. And then user defined, so constrains any of the 6 individual degrees of freedom in the specified coordinate system. And then we also have our connectors in here. So connectors, we're going to also see a couple examples of that as well. So auto connects the faces or surfaces of 2 components. Manual connects the faces or surfaces of 2 components as well. It's just you manually input the faces or surfaces. Bolt, so that simulates a bolt connection between parts using beam and rigid elements. And then we have edge, that connects nodes on an edge to the nearest node on another edge or surface. And then we also have our meshing group. So we're going to look at how we can edit our mesh and update our mesh. But that meshes the geometry in the active study. And then this solve over here. So this is where all the magic happens. So that solve executes the NX Nastran for the active study and displays the results in Solid Edge. So basically it's going to use, it's a lot of math, and it will display those results in Solid Edge for us. And then our last group here is our results group, and we'll look over how to see a couple different types of results and how we can go through all of our results. So let's go ahead and get started. Okay, so now we're going to create our linear study. So the first step to creating a new study is the new study command. And we are going to look at study type as well as mesh type. So for study type, we are going to stay on linear static, but we do have a bunch of other options here. We have normal modes, linear buckling, steady state heat transfer with linear static, as well as with linear buckling, and then transient heat transfer study, and a harmonic response. For right now, we are staying with this linear static. And then we do have several different type of mesh types. We have tetrahedral, surface, and mixed in general bodies. For the most part, we generally stay with tetrahedral. Surfacing is more for sheet metal. So we're going to go ahead and stay with tetrahedral. And we're going to look more at the mesh type as well as the mesh options in a little bit. But we do have this drop down here for our options. So these are for more advanced options, and these grayed out areas do come on based on what kind of study type you have. So instead of having a linear study, if I had a normal mode study, this number of modes as well as the frequency range will turn on. But for right now, I am going to stick with that linear study. And we're going to select OK. Okay, so the next step that we need to do is to define what components we are actually running this study on. So we are going to run it on all of the components that we can see here right now. So we can either go in and select all of these individually, or there's a button up here that is for select all. And then we can just click the green check mark and keep on moving. So now that I did that, I defined my geometry, we can see that my structural loads and my body loads, as well as my constraints, my connectors, and my mesh, I can now select. If and when I do the heat transfer study, we're going to see that the thermal loads will, as well as the function, will turn on. All right. So now moving forward, since I selected the geometry, I am going to apply a structural load to my model here. There is a drop down here for you to select. You can select face, edge, corner, point, or feature. I am going to select the face of this front bolt. And I can grab the steering wheel to help define the direction of my forces. So I drag that to a flat surface on the top, and we can see how my arrows moved. If I drag this to the left or the right side, you're going to see the arrows move as well. I do want it to go downward. So I'm going to leave my steering wheel here and come up here and say flip direction. So now we can see that my arrows are pointing down. I want a 3,000 Newton force coming down on that bolt. And we can see that we do have a feature handle like when we model in synchronous. So if I were to come in to my loads over here on the left hand side, select that force 1, can actually select that force 1 handle and edit my force command in this window. So now that we've defined our force, I'm going to also create a constraint. So for this, I want my pin to be completely fixed. I want it to stay exactly where it is. So for this drop down, instead of selecting face, I'm going to select the feature, come down here and select the entire pin. And we can see these little nodes that pop up for the fixture. I'm going to right click, and again we do get that control handle. And now I am going to create connectors. So like I said before, we do have the option between our auto connect and our manual connect. We're just going to use our auto for right now just to give a good demonstration of how that works. It's basically just a search distance of how close the faces are to each other, the features. So we are going to select all of our components. So again, I'm going to come up to this select all. I'm going to change my distance to 0.5 millimeters. And then I am going to look at my connector properties. So in case you want to come in here to update your penalty value. And then I'm going to go ahead and click the green check mark. And I'm going to get a results box that pops up here. So my results box, I can actually go down one by one and see where the connectors are. Okay, there's also this option right here. So this is called the toggle hide transparent, and as I go through all of these, we can see that that's transparent now. We can see through it, or I can just hide it completely. If I go to the next connector, again, I can select that box to show or hide. This is just an easier way to see your connectors. So these all look good to me, so I'm going to go ahead and create all of these connectors. So now that we've done that, we're going to go ahead and we're going to mesh our assembly. So we're going to go ahead and up here, we're going to select mesh. And for our tetrahedral mesh, we do have the option to make our mesh more coarse or more fine. We just use a little steering wheel here. I'm going to make it about a 6. We do have more advanced options when we select options. We do have mesh sizing, solid mesh, and surface mesh. But we're going to go ahead and mesh this. And what this is going to do is it's going to take those material properties and it is going to define how the model will interact with forces that are applied to it with that kind of material properties. So like max amount of stress that can be applied, strain. We're going to see that in just a minute. So it's fully meshed, and if we actually come over to the left-hand side here under our simulation tab, and we open this up, you can see that each part is actually independently meshed. And we can see next to our static study 1 that the 3 quadrants are now green, which means that all we have left to do is to solve this. So solving this is very easy. All we have to do is select this solve button. There is another solve in the mesh command as well. You can mesh and solve. But for right now, it is just going to solve this process, and then we'll take a look at the results. So here we can see our results. So we are looking at stress. There's a couple different ways to figure that out. On the left-hand side, we do have stress elemental. And then also for our data selection group, it's set to stress. There's also a drop down here for different kinds of stresses. So maybe if we wanted to see the X normal stresses that are applied to this model, we can see them there. Or if we wanted maybe the max principal stress, you can see that it's also been updated here. Okay, so the bar on the right-hand side is the bar that gives our values. If we want to see a specific value, we can also probe it. So over here on the far left-hand side, there's probe. We can either do it by nodes or faces. I'm going to do it by nodes at first. I'm going to pick a point kind of in here where I see that stress. And we can see that when I pick that point, I get a node as well as a value of my stress. There's also, if we drop this down, displacement. So we can see the displacement that's on this assembly with our force being applied. There are different kinds of display options. So if you want to see the contour, the deformation, the color bar, here's where you would come in and check those on and off. So this is the unformed model that I turned on. I can toggle that back off. We also have an equilibrium check. We have contour styles, so if we want to change this so it's a little easier, a little more easier for us to see. There's an ISO contour as well as this is called a banded contour. We can kind of see that the colors change significantly. There's also the element contour. But the smooth contour is what we kind of stick to for the most part. So this is going to change the deformation. So we have percentage, normalize, and actual, if you maybe don't want it to seem so significant. We do have the ability to create a report. We'll look at that at the next example in greater detail. But when we're done looking at our results, we can always say close simulation results. And it will take us all the way back out into our simulation tab. And what I want you to notice is on the left-hand side, those 4 quadrants are now all green, which is great. If I came and decided I wanted to delete this force out, this is just an example of what will happen. You can see now that one of the quadrants is now yellow. Okay, and if I try to, I can't even solve it if I wanted to. And if I try to mesh and solve, I can't even do that. So now we're going to move on to the heat transfer example. So while we take a look at creating our transient heat transfer study, we're also going to look at how the simulation bar changes. So when I come down and select that transient heat transfer, I'm going to get some options. So what my study to last for 2,400 seconds. I want a calculated time increment every 20 seconds. And I want it to be a constant. That's just for this example. And I'm going to keep the mesh type on tetrahedral. Perfect. And then all I'm really looking at is the transient heat transfer of our drum here, our rotor. So So again, working from left to right, the next thing we're going to look at is our body loads. So for this example, we are going to apply a body temperature of 20 degrees Celsius. And then we are also going to define a heat flux, so a thermal load. And for this example, we're going to act like this is the brake of a semi, and it is going to be going down a hill. And we're going to watch what happens when we apply the brakes and then apply the brakes halfway. So the faces that will be affected by the heat flux are these two faces right here. And I'm going to make that a value of 120 watts. And then I'm also going to use the convection command. So the convection command is going to let heat escape, and it's going to escape from all of the areas on here. So I just need to make sure I get all of the faces in here and all of the features. Perfect. Now I'm going to do that with a film coefficient of 50 and an ambient temperature of 20. So moving forward, this is a little distracting. So I'm going to go ahead and I'm going to turn off the loads on the left-hand side. And we can see that we're halfway done. So now is the time that I'm actually going to apply a function. I'm going to give this a function. So in here, like I said before, we're going to apply the brakes, and then we're going to apply them halfway. So from here, we're going to say at 0 seconds, there's a factor of 1. And then at 400 seconds, there's a factor of 1. And at 1,000 seconds, there's a factor of 1. And then at 1,400 seconds, there's a factor of 0. And then at 2,000 seconds, there's a factor of 0.5. And then at 6 seconds, at 2,400 seconds, there's a factor of 0.5 as well. So we're going to get this factor versus time map. So we're going to go ahead and save this. Say OK. So in our transient heat transfer study, we do have the function under here, our function 1. So now that we've created that function, I can go into my heat flux load and actually come in here and apply that function to our heat flux. And we will see the results after we solve it. And this time I'm going to solve it with the mesh and solve that's in the tetrahedral mesh options. So I'm going to go ahead and mesh and solve. And the first thing it's going to do is it's going to mesh the geometry. And then it is going to solve the heat transfer study. And we're going to look at a couple different ways that we can look at the results of a heat transfer study, and as well as a couple different ways of how Solid Edge 2020 gives us a few different options to look at the data and analyze the data. So then we just wait for it to finish solving, and we'll go ahead and move on to that. So as we look at the results, when we come over to our simulation tab on the left-hand side, when we go into our plots, we are going to have 121 increments, and that's because we're going to start at 0, and for every 20 seconds, we're going to create an increment up to 2,400 seconds. So that's going to give us 121 increments, including 0. So what we can do with these increments is when we look to animate, we're going to see how that changes with our increments. So in the data selection, we no longer have a drop down for changing necessarily temperature versus anything else. It's just temperature. But we do have these increment drop downs where we can select different increments. So if I start at 2, we can see how that's changing. We can see the different colors that are applied here versus maybe like 25, right? So Solid Edge 2020 does have the opportunity to provide us with graphing. So if I come up to my probe tool and I select, I'm going to select about 4 key points from here, and my probed points are obviously in basically this Excel sheet. You come in here, grab all 4 of those points, and produce a graph from that. And with this graph, we can see where that function comes into play, where it drops down here, where it dips down. We can actually save this graph, and it will be saved in our results right under plot. So that's a new function. We also have the capability of creating reports. So in this output results, I do have the opportunity to create a report here. So if I say simulation report, test, the author is me, company, PROLIM, today's date, instructions, conclusions, test, yes, it worked. And we can either create a web page or a Word document. But I'm going to go ahead and create a report. So we can see that a web page did pull up, and this is our simulation report. So what this is going to do for us is it's going to give us a document that has everything that we put into our transient heat transfer study. So I can go to loads, look at the loads that were applied, as well as our function, and maybe our mesh information, and then our results. I can see all the different increments of results, and then as I scroll down, I can even see pictures of that. I can zoom in and zoom out if I need to, but it's a very helpful tool for that. And that is all I have for you today for simulation in Solid Edge 2020. So thank you for everyone attending the webinar today. I hope you enjoyed my Solid Edge 2020 simulation webinar. My name is Grace Farrow. I'm a Solid Edge application engineer here at PROLIM. And if you have any questions, you are more than welcome to ask them in the chat box now. Thank you. Have a great day.